Hello everyone, this is Brady. Long story short, long time ago I've made a tutorial talking about how to distribute points in volume in geometry nodes when there is currently no such a node to do such kind of function for us. And at that moment I was only talking about a principle. So later people asking me some questions about it. The method is good, but there are limitations. It does not work for certain kind of geometry. That's why we're going to dig a little bit further to make another workaround, actually using the same principle to solve that problem. So let's start. So here we're in Blender, and this is a torus. So this was originally a torus, and we're trying to using the same methods as last time, in which we trying to creating shapes for geometry nodes to instance points on the surface. And when you look at the workarounds, this is array modifier. We have object offset set to empty. Empty is being scaled smaller. And immediately you can find this is not good because the geometry looks kind of very weird, especially if it goes to the X-ray. Because the torus is not traditional. It's not like the cube or UV sphere, or icosphere or cylinder. It has a hollow in the center. And this is probably also true when you're working with other geometry, for example, a human character or other kinds of mesh whose center point is not at its center of object. So you always have these kind of issues, and you have to deal with that. So today we're going to talk about a method. So here, even without the geometry nodes instances, we do realize there is an issue. So to solve that, today we're going to use the same principle, but using a little bit different methods, basically to create faces along with the normal of our object. So firstly, I'm going to delete this torus to make a new one. It's not necessary because this method really works for in almost whatever cases. And we do not need the empty anymore. You can just delete these empties, and we are not going to use object offset. So basically the principle is the same. We're still going to creating all these kind of faces, but we are going to displace everything along with normals so that we no longer bound with limitation, which is the center pivot points of our object. So now if we go to X-ray, we can see we have 11 surfaces being created with this array modifier, but a single displacement modifier displace all these kind of surfaces equally without a differentiation. So when all these kind of planes overlapping to each other, they looks like a single torus, while we actually are having more geometry. To differentiate everything, we're going to add a texture, because this is the moment when which usually people add a clouds modifier so that you're displacing the surfaces. Okay. But in this case, we're going to use blend. So now we switch to blend, and we can control every colors with a color ramp. It does not really matter in this case, because we probably do not really care. What do we really care is based on coordinates. You can work with UV global objects, but what's important, what's actually can create a differential between all these kind of layers is actually the UV. If you switch that UV, you immediately see kind of weird geometry. This is also interesting, just to roughly explain why it happens, is because if you're looking at the UV, just go to UV editor, and it looks kind of circular, but it has been UV unwrapped into a plane. That's why if you start with the left part, based on the color ramp that we saw earlier, this is the result. I think the cut is here. So it's basically true that if you mark your thing here, and the cuts center somewhere else. So basically it's kind of idea, okay? But here, we still do not really see any effect. It's still the same torus being displaced, even if we have 11 surfaces. But remember that you can actually offset UV. So offset by 0.1, you can see the entire torus looks the same, and if you go to edit view, it goes to X-ray view, you can see there's multiple layers being generated. But there's definitely some weird parts within this geometry. Like the some part is being expanded large, some part is probably small. So there is still this cutting being done, and that's why we're going to resolve that by, if I select all the kind of planes and just scale down to 0, immediately you do not see that cutting because we converged all the points into a single point. If you only distribute points, then you probably do not really worry about UV. Otherwise, you may would like to create another UV. This is also the principle of shader displacement in eevee, if you know what I'm talking about. But this is not the topic that we're going to cover today. Just to know that you always need to, how should I say, trying to make this offset always lower than this color ramp. So if you manage this color ramp in another level, you always need to keep these offsets at least 1/10 than the white. So now this white is at 1, the position is at 1, so we keep this 0.1. What if we keep that as 0.01? Then the displacement effect will be divided by even 10, so you have more dense mesh, so you need to increase the strength by 10, or you need to increase the count by 10. This is to get the same result. This is kind of idea. So the whole point is depends on how much you take the error modifier, because if you take this as 0.1 and take strength at 1, and there will be a point that no matter how you increase the count of error modifier, it will no longer displace itself. So this is the moment that you need to worry about, because if we fill with the 10, then this offset finally reach back to 1, so it will loop itself. So this is kind of idea, because outside of these regions, the UV map will tend to loop. This is also this is equally true when you're working with image textures in shader. Okay, this is the idea. So you need to be able to manage all this kind of difference. So you can take it to 0.05 so that it makes more dense. Also to mention, no need to mention that if you're trying to use error modifier, it definitely costs more geometry. But you definitely get all these kind of surfaces nicely based on the strength, and it's based on the UV. So now if we shrink backwards, not outwards but backwards, so we really fill all these kind of faces, or the entire volumes nicely without any problem. So once we achieve this, let's go to noding. Just goes to geometry nodes, just add a simple point distribute. Then we should have all these kind of points being instanced within the faces of this torus. Nicely, the central hollow is not being diminished. Everything just looks very nice. So this is kind of very simple, and you can deal with whatever you want. Basically the idea. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.